That's going to be the internal energy of sat vapor. And that's going to be pretty good. That's going to be pretty darn close. 2569.4. So I'm going to write that down here. I'm going to say U2 is about 2569.4 kilojoules per kilogram. Now we got something going on here. Okay? Because I've got a closed system. I don't use the enthalpy. Now, some of you might ask, why did I use the enthalpy for the example we did before? Because you were boiling water off and it was open. What was closed about boiling a pot of water? Nothing. This is in a rigid tank. All right? That's the difference. In most applications that we can visualize, we visualize open control volumes. Okay? Boiling a pot of water is an open process. Okay? But this is a rigid tank. Okay? This is a rigid tank. Okay? So this is closed. So we use U. All right? It gets a little confusing. In fact, unfortunately, I'm going to make it even more confusing next week when I talk about some stuff. But I'll try not to. I potentially could, but I won't. Okay. So there's my U's. I got both my U's. I got my U1. I got my U2. So take a look at this. I can just solve this thing here. Remember, my minus W is equal to M U2 minus U1. So M is 2 kilograms. U2 is 2569.4 minus 980.0. So minus W equals what? Somebody do that for me. 2569.4 minus 980 times 2.
3,178.8.
3,178.8. Good, thank you. And that's going to be kilojoules. So we're almost there. So the question is, how long does it take? Yeah. Now, go ahead. Question? Okay. Notice it's weird here. I know some of you are like, minus W equals 3,718.8. The work, the actual work, I can move this if you'd like. I can move this negative to the other side, right? The actual work is negative. Why is that? Because you're putting energy in, so that's why it's negative. So the actual work is negative 3,718.8 kilojoules. Yeah.
So we can just keep it as a positive?
You can keep it as a positive because you know it's in. That's all you know. You know it's in, right?
Yeah.
And then the work, the power, remember the power is 880 joules per second. Okay. Yeah, how about the power in joules? How about we do that? Or either way. Oh, how about the power in kilojoules? That's what I meant. Let's put the power in kilojoules. That's the same as 0.880 kilojoules per second, right? So my actual time, remember, power is equal to work divided by time. Okay? To solve for time, it's going to be work divided by power. It's going to be 3178.8 kilojoules divided by 0.880 kilojoules per second. So it's going to be a pretty big number of seconds. 3,178.8 divided by 0.88.
3612.3.
About 3,600 seconds. What's 3,600 seconds? An hour, right? So it takes about an hour. It takes about an hour. Cool.